Welcome to part 3 of our video. We're finding a p-value for a 1 proportion z-test. First, we used the 1 prop z-test menu, and that was a very easy way to just type in what you know and get a p-value. Next, we saw that what the menu is actually doing is it's calculating your p-hat, which is your sample statistic, and it's finding the area under the normal sampling distribution that corresponds to your null hypothesis to say, how likely were we to see a result that was that extreme or smaller if the null hypothesis is actually true. So to do that, you have to calculate the standard error, which is the spread of this sampling distribution. The traditional way of doing it is we're going to use the standard normal distribution. And the standard normal distribution is a normal distribution, but it's centered at 0 with a standard deviation of 1. And you can think about this as a distribution of z-scores for whatever normal distribution you might be thinking about. So what we're going to do is we're going to take our p-hat, which was 0.1692, and we're going to use it to find the z-score. The z-score calculation you learned way back in Unit 1, and the calculation is always your particular result minus the center of the distribution divided by the spread, which sort of makes sense like this. If I have, let's say this is 0.1692, if I say 0.1692 and I subtract the center, which is 0.2, that's telling me what this distance is. I'm saying this distance minus this distance gives me the distance in between. So that tells me how far away I am from the center. But right now it's in units of it's like the proportion units. So not percentiles, but percentiles divided by 100. But a z-score doesn't tell me how far away I am from the mean in the units that my experiment was in. It's supposed to tell me how many standard deviations. So like, let's say the standard deviation here was this long. Here, just visually, you could see, oh, I'm about 2 standard deviations away from the mean. So in order to convert units to standard deviations, I need to divide by the size of the standard deviation. And the size of the standard deviation is my standard error. So 0.0496. So again, it's nothing new about z-scores. It's your result minus the center over the spread. But the only difference is now the spread of the curve is a standard error. So the z-score is the same thing that the menu reported over here. The z-score is negative 0.6202, which should make sense because our result is to the left of the mean, and so the z-score should end up being negative. So this is negative 0.6202. And now I want to find this area. And you could do the same thing using normal CDF. So my lower bound will be negative infinity, but this time my upper bound will be negative 0.6202 with a standard, with a mean of 1 and mean of 0 and a standard deviation of 1. You paste it in, and that should give you a p-value that tells you the probability your z-score is going to be smaller than that. So I'm writing the same thing that I have on the left side. Okay, you might wonder, if we're using normal CDF in both cases, why bother calculating the z-score? Why not just type in all the information you know about your sampling distribution? And the answer is, if you have a computer, yes, you can definitely do this. Back in the olden days, before we had these nice computers in our hands, the only way to find these areas was somebody published a book which will tell you for different z-scores what's the area to that z-score's left for the standard normal distribution. And so you would look up in the book, you'd say my z-score is this, what's the area? But that only works if everybody agrees to center the normal distribution somewhere. If you wanted to center the normal distribution wherever your particular experiment was, we would need a different book for every single possible center and spread. So by normalizing it, that means that everybody was able to actually find these areas by looking them up in a single book that everybody had access to. Is there any reason to do this anymore? Not that I know of, at least not for this particular purpose. But it's still nice to be able to think back and forth between a standardized test statistic, which is the z, and a regular test statistic, which would be your p-hat.